Autermann from 52 North. We will talk about the OGC API.
It's on Autermann. Oh, no. Not 11. Where's the presentation mode? Do you know that? So, hi everybody. I'm Autermann, and probably this will be the only talk where no marine data at all is relevant. So I want to talk about the OGC API connected systems. So this will be a rather technical talk about new technologies developed by the OGC or at the OGC. But very short, 52 North, many may don't know me or us. We are a research and innovation company based in Münster, Germany, around 25 to 30 people, doing a lot of applied research, knowledge transfer from research to businesses to everything. We are doing a lot of open source software, so everything we are doing is open source and can be accessed at GitHub. We are doing a lot of research projects, not only in the marine domain, but across a vast landscape of research domains. But we're also doing research, professional services for private companies, for governmental agencies, and so on and so on. We're owned by the two universities, the University of Münster and University of Twente, but also private companies, Contera, which is also based in Münster, and S3 Inc. from Redlands, USA. So the OGC API connected systems, what is it? Some of you may know the sensor observation service and sensor planning services to OGC standards from the sensor web domain. So services to handle observational data, operational data, to task sensors, for example, to take a measurement, to take a sample. And those are quite old right now. So I think the last version of the SOS was 2012 or something like that. The last version of the SBS is, I don't even know. And we are currently working on a true successor to these two standards, which is then called the OGC API Connected Systems. I didn't come up with the term. I'm not really, not that keen of that. I would have liked to have it called OGC API Observations or OGC API Systems or something like that. But this is the name, and it combines the SOS and the SPS under the new umbrella of the OGC API family of standards. I will come back to that in the next slide. So it's an API for management of sensors, platforms, actuators, also observations, data streams, and all this in an OGC interoperable way. And we as 52 North, we are not the main developer of the standard, but we are heavily involved in the standards working group and also doing an implementation right now. So what are these OGC APIs that are coming up? Those are resource-oriented HTTP APIs. You could call them REST, but there is something to REST that they don't have, but let's call them REST APIs. They are based on JSON and JSON schema, especially open API specifications, and consist of, so to say, building blocks. That's the word, the OGC words for that, takes for that. So we have schemas, data types, parameters, and APIs, and all these are considered building blocks. These are not monolithic services we have known for the past, but we can take an OGC API processes that creates an OGC API features collection as an output, and so on and so on. You can stick that together to have a usability between the services, between the standards, and also compose them to create your own services. So what do we have until now? So many of you, this time many maybe, right, know the web feature service and the web map services. These are the most prominent examples of these old generation services from the OGC. And there are currently developments to not replace them, but to create an update, a newer version, a more modern version of these services. And basically for each old service, we now have an effort to create a new one. Most prominently, we have the OGC API features, which is a replacement for the web feature service, which is also already standardized and published, and you can use it, and it won't change anymore. But we also have replacements for the catalog services. This will become the OGC API records for the processing service, the processes, coverages, maps, tiles, and so on and so on. There are a lot of things. There's also an API for routing and so on and so on. So they are really getting kind of out of hand to keep track of them. And one of those is the OGC API connected systems. And you may ask, yeah, we have the OGC Sensor Things API, which is another web standard and is kind of REST-based and is JSON and so on and so on. But in our opinion, it lacks some stuff. For example, it's based on OData. If you ever used an OData REST API, you're really happy with that if you use it, but you hate it if you want to implement that because it's really painful to do that, and especially it's really painful to do it on top of existing systems. So if you have an internal web service that offers observations and sensors and so on, and you would like to offer that in an interoperable way, you basically have a really hard time to put the Sensor Things API on top of that. You basically can query the complete database in one HTTP request, and it's really hard. And most important, it lacks support for detailed sensor descriptions. So you have basically a GeoJSON feature, and that's your sensor. That's it. Nothing else is specified. That's something we want to work on, and we are using the existing standards we common in SensorML, which you may know, but updating them to a new version, so there will be a 3.0 release of them. We are deprecating the XML encoding. We don't think anybody will use that anymore. We have a JSON encoding. We extended some things, so for example, we can now really encode. We have a deployment of an AUV with these systems on board, and so on and so on. So we have deployments as a top-level element there, and we have the actual specification of the OGC API, which is currently a 5-part specification. You may know from the past there's a WFS 1.0, and that's it. OGC kind of going the agile way and just pushing around part 1, 2, 3, 4, 5, and so on, and that's the way we are doing it right now also. Short description of the different parts. So most important are part 1 and part 2. Part 1 is about non-changing features. So we have systems, we have descriptions of sensors, of sensor systems, but also of actuators. We can describe what procedure this system is implementing. So if you have a temperature sensor, we can describe that in general, and then describe this actual implementation of this of the sensor. We can maintain data sheets of sensors and then the actual instances of them. We have deployments, as said. We can encode how the different systems are deployed in the field. We have sampling features where we can encode what we have sampled, and we can create hierarchies between systems. So we can model the research vessel having a GPS sensor in the front and then the back and so on. We can encode that. And we can create derived property definitions, which is kind of new. We couldn't do that in the SOS, and that is something we wanted. So if we have a term from a vocabulary server, we can reference that and just say this is not only temperature, but this is the temperature of the car engine or something like that. So we can create semantic derivatives of vocabularies in this API itself. Currently, we have 2 encodings. So if you want to go the hard way and encode everything you want in the metadata, you go for SensorML 3.0. But we have also a more lightweight way, so you can just encode your sensors as GeoJSON and put whatever you want in there. And we have a kind of a mapping between those 2. One thing to say, this part 1 is basically an OGC API features, so we are just a specialization of the OGC API features, or in the past WFS. We just say which collection in this API has what metadata format, in this case SensorML or GeoJSON, and we are just saying we have these collections. But the OGC API Connected Systems Part 1 is basically an OGC API features. In Part 2, we are handling dynamic data, so basically observations and data streams, control streams and commands, and also events and the history of sensors. Data streams offer access to observations produced by systems. We can aggregate some of the metadata of the observations. If you have used the SOS, it could be some kind of verbose. If you have a really big XML description of your data, and you can aggregate that into the data stream and have just the values and the timestamps in the extra data streams. As said, observations, we can encode that in any way you want. You can use protobuf, XML, JSON, whatever. We don't really care, but you can describe how it is encoded. And you can also link to external services like AirDrop or OGC API coverages. Also, we have control streams. This is the upstream part of the Connected Systems API, where we can send commands to sensors. We can describe how these are structured and how these should be encoded, and we can also see how they are executed. And the last thing, we have events and history. So in the past, we had to encode events that, for example, calibrations that happen to a sensor inside the sensor ML description that would grow indefinitely over the time. And that's why we put that at the top level element. And now, in very short, the last three parts, we are also working on a pub/sub mechanism, so we can subscribe and publish via MQTT, observations and commands. Part 4 will be about sampling feature types, so that you can encode, for example, a viewing frustrum as a sampling feature. We are getting to binary encodings in part 5. And last but not least, it should be out this year. We planned June, but it won't work because we have a dependency of OGC API common. And we're also having an implementation on PyGeo API. Get to me if you want to try that out. PyGeo API is an implementation of all these API standards, if you don't know that. Thank you. Short questions.
Thank you. Question there.
Hi, Christian. Thanks for this presentation. And I was wondering, actually, when this is going to happen.
It was planned to vote on it in June for part 1 and 2, but we have a dependency on OGC API Common, which has a voting period of 6 months, so we're hoping for the autumn, but we don't know.
Okay, because there is no standard that is available that actually describes the sensor so well as sensor ML, but we didn't want to use it because it's XML and it's quite old-fashioned.
You can use the draft standard. Sensor ML won't change anymore, so that's basically done from our side, except for some people raise comments or concerns. Then it may be changing, but the sensor ML is quite stable.
So are you going to provide a mapping between sensor ML2 and sensor ML3 so that people that want to upgrade can do that semi-automatically?
Maybe we won't have the tooling for that, but it's basically one-to-one. We just added stuff and deprecated XML. So it should be really compatible.
Okay, thank you. Really nice to know that.
Questions? Dick? Okay. No, you can go here.
No, thank you for the information, because let's say we heard about this OGC API coming. And of course, you are our specialist in our group, let's say, helping us to understand it better. And but I was wondering, let's say, you are not yet at the level of pilots, or are you already? Are you looking for volunteers, let's say, operational oceanography networks, for instance, let's say, I want to try it out? Because
we're actually doing that in some projects. So we have a presentation about the Minke project in the afternoon, and there are we using that, and also in some other projects. In MONet we will also use it.
Yeah. Okay, so you have
But
already...
it's not at the stage that you would really use it in an operational way, I think, because it's not yet a standard.
No, because I'm asking, because we, of course, when we worked on the, let's say, the older one, let's say the sensor web enablement, we always had this, it was difficult, let's say, to sell it to operators, because it's initially a lot of work. They have to map, let's say, they have to describe all the sensors and platforms. At the same time, of course, when they have done it, and they have a quite stable network, it's fantastic. Because that's what we see in the presentation of Alexandra. We are missing this information afterwards if we want to use it. And if the operators would have installed it immediately, take that effort. Of course, from that moment on, you can simply use it and push it forward in the metadata, make it more fair and more useful for the users. So that's why I'm asking, are you planning you need some very good, let's say, demos, pilots, by which we can convince the community.
Yeah, we are definitely working on that.
Okay.
Yeah, thank you very much, because we are getting back to the initial point, and this is good to make a connection. There is another question. Go ahead.
Hello, Ute Brunner here again. I would like to second what Dick said, because what I have noticed is that standards are developed, but everything with sensors in the ocean is extra difficult. So I would like to censor that, to work together with a pilot, and I'm volunteering as well as a pilot if you need one.
Okay.
Thank you.
Hi, I just wanted to ask, maybe I missed it, but at the end you were talking about implementations. Are there any plans to implement the OGC API in GeoServer?
This one, not from our side at least. And GeoServer is currently, I think, looking for funds to implement the OGC API features. So they are lacking the funds to do that. So if anybody wants to volunteer and contribute, we are currently working more on the Python, on the PyGeo API side, yeah. Because GeoServer has some, yeah, if to get into that big piece of software, there's some efforts needed.
Yeah, thank you.
I think we're done now for